All right, welcome everybody. Today we're going to talk about Calc Lesson number 54, but before we do so, we need to give you a little bit of a disclaimer. If you can believe it, we have officially reached 1 year in terms of the anniversary of the content of when Ms. Patrone and myself started making videos. So hopefully you can understand why, in terms of being efficient, it doesn't make sense for us to record these videos again. We are going to edit them, however. So we're going to make sure all the numbers match and make sure all the homework matches. But within the videos, if we refer to something that doesn't apply to this year, but did apply to last year, please make sure that you just disregard. We'll try to catch those things ahead of time, but in case we miss anything. Also, please keep in mind that some of these lessons coming up were the very first lessons that Mr. Chone and I made last year. So we didn't have devices that were as good as this year. We also weren't as seasoned as making videos as we are now. So again, please be kind for the next couple of lessons, since technically they were made last March when we were kind of just entering lockdown. So that being said, we are ready to finish chapter 4, and that is all about section 4.5. We're going to be here for the next couple of days, and each of those lessons is going to talk about integration by substitution. And then the first lesson for today has to do with something called pattern recognition. Notice here, I have the homework written on the front slide. Again, that was because of editing purposes. It's just easier to do so. So please make sure you jot down tonight's homework. It's in the book, section 4.5, page 301, number 5 to 15 odd. So in order to best continue our discussion about integrals, we have to go back to derivatives for a second, and specifically, we have to go back to the chain rule. As we've worked through chapter 4 so far, we have told you that there are no formulas for how you would integrate something that would require the chain rule, the product rule, or the quotient rule. And the truth is, the reason why is because in order to integrate those more complicated examples, you need to use this process called substitution. So again, these examples are in your notes. They're blank, so you'll want to fill them in as I just remind you what it means to take the derivative using the chain rule. So here in number 1, 5 times 2 minus 7x to the 4th. Hopefully it hasn't been so long that you forgot. You're going to go ahead and bring down the 4. 4 times 5 is 20. You would then take the entire quantity to the 1 less power, which would be 3. And then the chain rule says you're going to take the derivative of the inside, which would be negative 7. In your final answer, multiply the negative 7 times the 20 and put that out front, times 2 minus 7x cubed. So again, if you think about what we're about to do for the next couple of days, you're going to start with an answer like this and somehow try to integrate it to get it back to this original problem. So we haven't really seen complicated examples like that so far, but we will see a bunch of them here in section 4.5. So number 2, the sign of 2x. Remember, when it comes to the chain rule, you're kind of thinking of it in terms of composition, the f and the g, the inside function and the outside function. So this function on the outside, the sign, that would technically be your f, and then the function on the inside, the 2x, would technically be your g. You would take the derivative of the sign of something, which is the cosine of that same something, times the derivative of the inside, which would just be 2. In your final answer, go ahead and put the 2 out front. For something like number 3, take the 3, bring it down to the front, take the entire quantity to the 1 less power, take the derivative of the inside, and there really isn't much simplification that can be done from here. Finally, for number 4, that was kind of as hard as it got back in the derivative chain rule days. So sine cubed of 4t, the first thing you would have to realize is that you can write that as the sine of 4t, the whole thing cubed. By writing it as something cubed, the first step when you take the derivative is using the power rule. So you would bring the 3 down to the front, take the entire sine quantity to the 1 less power. Then you would have to take the derivative of the first inside, which would be the sine of something. So the derivative of the sine of something is the cosine of the same something. Then you would have yet another chain rule. You'd have to take the derivative of the 4t, which would be 4. And then if you go ahead and multiply out that entire expression, you're going to go ahead and get this final answer here. Now, I don't know that you'd be asked to integrate something quite as complicated as this final product, but in order for you to be able to understand how integration by substitution works, you do have to refresh yourself here on taking the chain rule derivatives. So a little bit about pattern recognition. Again, the two different ways you're going to be asked to do integration by substitution is either by using pattern recognition or by using something called U substitution. So with pattern recognition, which we're going to talk about today, you basically are doing the substitution mentally, which means that the problems have to be relatively simple. Our next couple of lessons are going to focus on U substitution, which is where you actually go ahead and change the variables. If you're talking about pattern recognition, you first have to, again, remember back to derivatives. Think about when we were taking derivatives of compositions, which of course means that one function is inside of another function, in this case, the g inside of the f. When you went to take the derivative of f of g, you would take the derivative of the outside function, which would be f. Then you would take the derivative of the inside function g, which would be g prime. So if the derivative of f of g is as follows, then it should make sense that if you're doing the other way, meaning taking the antiderivative or the integration, in order to integrate, you have to have all the different components. You have to have the original derivative, and then you also have the derivative of the inside. Since we are back to indefinite integrals, all of the answers for the next couple of sections are going to end with plus c. This is kind of similar to the previous slide. Again, this here is talking about how you're integrating using patterns, and then the U's is what we're going to talk about next time. A little more before we actually get into the problems. The only way that you can integrate some function that involved the chain rule is if you have the original composition, f of g, and then if you have the exact derivative of the inside, which would be g prime. If all those pieces are present, then you would just go ahead and integrate as per usual. If all those pieces are not present, then you're going to have to go ahead and make some kind of compensation, which is what this lesson is about. So this is number 1 and number 2. Again, if you're following along on the worksheet, feel free to fill them in. If you're just taking them in your notebook, then feel free to pause this slideshow at any time and take notes. You can, of course, go back and watch this slideshow as many times as you would like. So for problem 1 here, we are trying to use pattern recognition to take the integration of this function. The first thing that you're always going to do when you try to do these more complicated integrations is you're going to try to identify what the f of g is. So the f of g means which of these two pieces is the more complicated one, which I think it's pretty clear to see that it's this. So this right here is your f of g, which means that in order for this to work, whatever is on the outside has to actually be the exact value of g prime. So if you take a look at your f of g, your inside function is x squared plus 1. The derivative of x squared plus 1 is 2x. So that means you have exactly the derivative outside that you need. If you have the exact derivative outside that you need, then you are free to integrate as you normally would. So you are trying to integrate x squared plus 1 squared. You're going to do that by taking the entire quantity, x squared plus 1. You're going to raise it to the 1 higher power. You are then going to divide by that power. And don't forget the plus c. And again, this would be perfectly fine if you also factored out the 1/3 x squared plus 1 cubed plus c. So again, in a nutshell, what you're doing is looking at the problem, identifying the more complicated piece, naming that f of g, looking what else is present in the problem to see if you have g prime. If you do, then integrate. If you don't, make a compensation. So here for number 2, 5 times the cosine of 5x. Identify the more complicated piece, which in this case is the cosine of 5x. This would again be your f of g. In order for you to be able to integrate, whatever is on the outside has to be g prime. So cosine of 5x, if you were to take the derivative of the inside, the derivative of 5x would be 5, which again means you have exactly what you're looking for. So you're free to integrate the cosine of 5x the same way you normally would. So looking at your green sheet, the integration of the positive cosine of 5x would be the positive sign of 5x, and then don't forget plus c. For any of these integration problems, the best way to check that your answer is correct is to then take the derivative. If you were going to take the derivative of the sine of 5x, the derivative of the sine of something is the cosine of the same something times the derivative of the inside. So feel free to use derivatives to check any of your answers. Let's go again. So x squared minus 9 cubed times 2x. That would mean that this right here was your more complicated f of g. The only way that the problem can be done is if what you have on the outside is exactly equal to g prime. In this case, the derivative of x squared minus 9 would in fact be 2x. That means you have exactly what you want outside with g prime. So you're free to integrate x squared minus 9 cubed the same way you normally would. You're going to take the entire quantity, x squared minus 9. You're going to raise it to the 1 higher power. You're going to divide it by that power, and then don't forget the plus c. Now, if you're thinking that this is easy, it is for the next couple of examples, and then I'm going to show you what happens if you don't have exactly what it is you're looking for. So in the next problem, I'm going to go ahead and start by rewriting this problem. I'm going to rewrite it as 3x squared, and then I'm going to write it as x cubed plus 1 to the 1/2 power. If you are going to be integrating, you have to know what your exponent is. So x cubed plus 1, this continues to be f of g. You are looking at whatever is on the outside, and you're trying to confirm or deny whether that is in fact g prime. The derivative of x cubed plus 1 is in fact 3x squared. We have exactly what we were hoping for, which means we are ready to integrate. You're going to take your quantity, x cubed plus 1. You're going to raise it to the 1 higher power. So 1 higher than 1/2 would be 3/2. Don't forget to divide by that same power. And then, of course, we wouldn't leave our answer like that. We would multiply by the reciprocal, which would be 2/3. X cubed plus 1 to the 3/2 power, and don't forget the plus c. So that's kind of the end of the easy problems. I would encourage you that if you did not understand those easier versions, maybe go back and watch again before we get to the more complicated examples. So in the more complicated examples, let's take a look here. Start by identifying f of g. And then take a look at what you've got on the outside. So in this case, all you have is an x. If you were to take the derivative of x squared plus 1, you would of course get 2x. So that means that you have an x, but you needed it to be 2x. That means that somewhere along the way, a 2 got canceled, which means you have to put that factor of divided by 2 into your answer. So now that we realize what we need, we're going to integrate just like we normally would, but we're going to go ahead and make this compensation. So to start, take your quantity, x squared plus 1, raise it to the 1 higher power, which is divided by 3. And then because of the fact that you only had an x, but you need a 2x, you're going to go ahead and add a divided by 2 here into the denominator. The reason why you add it into the denominator is because if it should have been a 2x, but it wound up only being an x, that means that the 2 needed to cancel, and a 2 can only cancel if it's in the denominator. Now that you've made the compensation, just simplify. So 1/6 x squared plus 1 cubed plus c. Again, these problems are going to get much more complicated over the next couple of days, but for today, they're really pretty simple. If you want to check your answer, remember, take the derivative, don't forget the chain rule, and you see that this should work perfectly. In the next example, f of g, the derivative of 6 minus x cubed should be negative 3x squared, which means that you don't have exactly what you're looking for. So again, that means you're going to integrate like you normally would and then make a small compensation. So start by taking the quantity 6 minus x cubed, raise it to the 1 higher power, divided by that same power. And then because you needed a negative 3x squared, but you only had a positive x squared, you're going to have to add in a negative 3 in the denominator. A little simplification, negative 1 over 18, 6 minus x cubed to the 6th, and of course, try not to forget the plus c. If you are feeling like you are understanding what's going on, again, you might want to pause this video, go ahead and try the next 4 problems, and then when you're done, come back and make sure that you've done them correctly. If you feel like you need some additional practice, then let's just keep going. In our next example, take a look at the more complicated part. That's f of g. The derivative of x squared plus 1 should be 2x, which means we have exactly what we're looking for. As long as whatever you're looking for is present, you're going to go ahead and just feel free to integrate as per usual. So you're going to take your x squared plus 1 to the 1 higher power. You're going to divide by that power plus c. And again, whether you leave it as divided by 5 or factor out the 1/5, it really doesn't matter. For the next problem, I would strongly recommend that you take that cube root and rewrite it as a 1/3 exponent. If you identify f of g, the derivative of the inside would be negative 8x. That means you have exactly what you're looking for, so you're free to integrate. You're going to take 3 minus 4x squared. 1 higher than 1/3 is 4/3. You're then going to divide by that same power, no compensation necessary, and then simplify your final answer to be 3/4, 3 minus 4x squared to the 4/3 power, and of course, plus c. Let's go ahead and hit up our last 2 problems here. So take a look at the more complicated f of g. The derivative of the inside should have been 10x. That means that instead of x, we actually needed it to be 10x. So as we go to do our integration, we're going to go ahead and make that compensation. So you're going to take 5x squared plus 4, raise it to the 1 higher power, divided by that power, and then because of the fact that you needed a 10x but only had a regular x, you have to add a 10 into the denominator. Simplify will give you an answer of 1/40, 5x squared plus 4 to the 4th plus c. Last but not least, again, I'm going to start by taking that 1/2 power and rewriting the square root so I know exactly what I'm doing. Look at the f of g. The derivative of the inside should be 3x squared. Since I only have an x squared, I'm going to have to go ahead and make a compensation. So take your x cubed plus 1, raise it to the 1 higher power, which is 3/2, divided by that same power. And then because you needed a 3x squared, but you only had a 1x squared, you're going to have to add a 3 into the denominator. On the denominator here, 3/2 times 3, that is 9/2 in the denominator, which means when you multiply by the reciprocal, you're going to get 2/9 x cubed plus 1 to the 3/2 plus c.